7.4.0, the introduction to factoring, which is reverse multiplying. We are going to be finding the greatest common factor of polynomials. In a multiplication problem, the numbers multiplied together are called factors. To answer a multiplication, the answer to a multiplication problem is called the product. In the multiplication problem, 5 times 4 equals 20. 5 and 4 are the factors, and 20 is the product. If we reverse the problem, 20 equals 5 times 4, we say that we have factored 20 into 5 and 4, each factor. Factoring polynomials. In the problem, 2x times x plus 4 equals 2x squared plus 8x, we say that 2x and x plus 4 are the factors, and 2x squared plus 8x is the product. We can check this. 2 times x is 2x squared, and 2x times 4 is 8x. If we reverse the problem, 2x squared plus 8x equals 2x times x plus 4, we say that we have factored 2x squared plus 8x into its factors, 2x times x plus 4. So factoring puts a product back into its multiplication form, its reverse multiplication. So now all we're going to do is name the factors and products in each of these problems. So let's find the product. 5 times x is 5x. 5 times negative 7 is negative 35. The factors were 5 and x minus 7, and the product is 5x minus 35. 3 times x is 3x squared. 3x times 9 is 27x. So the factors are a 3x and an x plus 9, and the product was 3x squared plus 27x. Negative 10x times x is negative 10x squared, and a negative 10 times a negative 6 is a positive 60. The factors are negative 10x and x minus 6, and the product is negative 10x squared plus 60. And finally, 4xy squared times 3x. You do the numbers first. 4 times 3 is 12. And then an x times an x is an x squared. And then the y squared comes along for the ride in that first term. And then 4 times 8 is 32. X comes along for the ride. And y squared times y is y cubed. So the factors are 4xy squared and 3x plus 8y. And the product is 12x squared, y squared plus 32. Oh, I'm sorry, this one was a 60x. I apologize, because it was negative 10x times 6. 32xy cubed. So what we're going to be doing next is we're taking these products and we're going all the way back to its factored form, where the factors are being multiplied together. So the first step in factoring polynomials is to factor out the greatest common factor. So it's the largest whole number and highest degree exponent of each variable that will divide evenly into each term of the polynomial. For the variables, it actually ends up being the smallest exponent between them. So like it's the least amount that they overlap by. So it ends up being the smaller of the two. And we'll see that in just a second. So let's find the GCF between the following monomials, and we're going to use that to help us factor the polynomial using greatest common factor, GCF. So what is the value that can divide both 9 and 45? Now, the common answer is 5. But think about, does 9 divide by 5? No. You came up with 5 because you know that 9 divides 45. So that means that 9 divides 9 and 9 divides 45. So the greatest common factor between 9 and 45 is 9. This monomial has an x, and this 45 does not have an x, so they do not have any x's in common. No x's. So now when we use that to factor a polynomial, this greatest common factor becomes your first factor. And now we divide. 9 divided by 9 is 1, and I'm left over with a single x. 45 divided by 9 is 5. And now if we check this, if we do 9 times x plus 5, if we multiply that, 9 times x is 9x, and 9 times 5 is 45. Yay, that's what we wanted, 9x plus 45. So you can always check your work by multiplying it back out. So what's the greatest common factor between a 7 and a 21? Well, it's another 7. And then if this one has x squared and this one has x, the least amount that they have in common is one single x. So 7x is your greatest common factor. So 7x comes out front. It had x squareds and a 7, but I took the 7 out and one x out, so it leaves me with a single x left over. Minus 21 divided by 7 is 3. And I took it, that has an x, I took an x, so we close it up. Another way to think about this is that this is a 7 times an x times an x, and this is a 21 times an x. So thinking about what they have in common, they have a single x in common between them, and that's why it was a single x that we brought out front. And then you're subtracting the exponents. So if you pull out a single x, 2 minus 1 is 1. 1 minus 1 is 0. Let's try another one with larger exponents. What's the greatest common factor between 18 and 12? Well, they both divide by 2, but that is not the greatest common factor between them. The greatest common factor is 6. 6 divides 18, and 6 divides 12 evenly. The smallest exponent between them is x cubed. So 6x cubed is the greatest common factor. So 6x cubed comes out front. 6 minus 3 leaves us with 3 x's. 18 divided by 6 is 3, so 3 and 3 x's. 12 divided by 6 is 2. 3 minus 3 is 0, so we close parentheses. The greatest common factor between 15, 25, and 55 is a 5. And the smallest exponent between them is a single x. So the greatest common factor is 5x. 15 divided by 5 is 3. 3 minus 1 leaves me with 2. 25 divided by 5 is 5. 2 minus 1 is 1. 55 divided by 5 is 11. 1 minus 1, the x's go away, so we close parentheses. Now let's try some examples on the back without doing the greatest common factor bit. What's in common between a 5x and a 35? Just a 5. 5 divided by 5 is 1, and there's 1x left over. 35 divided by 5 is 7. What's in common between a 3x squared and a 27x? A 3x. X plus 9. 12 and 32, the greatest common factor is 4. X squared and x, the lowest amount is an x. Y squared and y cubed, the lowest amount is a y squared. So then 3x and no y's, and 8, no x's, and 1 y. 6x, x minus 4. 14 and 35 have the greatest common factor of 7, and then they have an x in common, 2x minus 5. This one's trickstery. What's in common between a 5 and a 1? A 1. So then you skip the numbers and you go straight to the variables. What's in common here between an x squared and an x? Just a single x. So then I get a 5x. And then what's an x divided by x? It's actually a 1, not a 0. So think about multiplying this one back out. If we have an x times 5x plus 1, x times 5x is 5x squared. And then if you didn't have that 1 there, you wouldn't be able to get the x times 1 to make that x back. So you have to have the 1 in order to multiply back out. 3x cubed, and then a y squared. So then we get an x plus 5, and then the x's went away, and 1y. 20, 15, and 30, 5, and a y squared is the smallest one. So then we get 4. 6 minus 2 leaves me with 4 y's. Minus 3 single y plus 6. Now these last two have negatives on them. So what you do is you pull out a negative greatest common factor. So the greatest common factor between these three is -2 and then a single m. So then we have 6 minus 1, m to the 5th. 14 divided by -2 is -7 and a single m. And a -6 divided by -2 is a +3. -5, x, and a y. So then we get a single x and a -7. You could always write that as -5xy times x minus 7 as well. Thank you.